Hello everyone. Now that we have covered the basics, let's talk about how to create new views. The first thing you do when you see a new design is actually you have to make a decision to what kind of custom you want to make. And you have four decisions. Uh, you can either extend the view directly, or the subclass of the view, or extend view group, or view group subclasses. Um, I have to mention that view group subclasses sometimes have the behavior of their own, like date picker, that they are called compound views. It's just good to know. The first case of which is extending the view class directly. As the view is a bare class, it means that you want to work with the draw method. Draw everything directly into the canvas and show what needs to be shown to the user. It happens in cases that the design is a whole new invention, which means there is nothing similar to it in the existing views. Like it's a graph, you want to show a graph, or like a speed gauge, or anything that like is a whole new thing, you will have to draw it yourself. The other case in which it happens is for performance. It happens like in cases that you have a complicated design with many stuff to show to the user, and if you implement things using the conventional views and view groups, you will get a complicated layout, and since all those stuff are made for general purpose, it means that showing what you want to be shown will get a much larger amount of code to process, and hence will be slower. But if you draw them directly and bypass all those extra calculations, you will get a much better performance, and your app will be more smooth and gets a much better feeling. The cost of it though is that you will have less flexibility in your code, since you are implementing everything directly in code, putting everything where you want it to be, and so for every change in the layout you will have to touch your code, which will be a labor actually, but it's worth it. For example, for the performance example, like in the Instagram app, each post that you see, the images, the comments, posts, likes, sometimes it shows a few comments too, it's all a single view, and they have done this for performance. The other example is the messages on the Telegram application, also is the same. And you can actually check this if you turn on the show layout bounds option in your developer options. You can see every view separately. It will draw a box around every single view, and you can check different apps to see how they are implementing their stuff and get a feel of it. The other option is to extend the view subclass, like the image view or text view or anything else, and you do this when the behavior you need, the thing you want, is similar to an existing view. And doing this, you have to do this whenever you can, because you will be writing much less code, and also you will have much more flexibility because they have already taken into account every modification that might be required, and so you will be able to use that and spend much less time creating the view. You will also take advantage of all the knowledge that is put into the view. They have done a lot of performance optimizations, taken into consideration everything like the accessibility stuff, and you will get the hold of all of that, and it will be great. You have to choose to extend an existing view subclass whenever you can. The challenge here is to have a good knowledge of the view you are extending, because sometimes the view is not made for what you want to do with it, and so it will be slow to use it that way, and you will not get a good performance, and it will not be great. In other cases, the view you're extending might have a behavior that you are not aware of or not expecting, and in the result, you will get bugs. So, but this one you will have to just do it by experience. Just keep doing it, and every time you have a challenge, you will go fix it, and you will get better at it. The other option is to extend the view group or class. There are two main scenarios in which you do this. One of them is to implement the screen-wide interactions, like you have a behavior that is applied to the whole screen. Like you want to have a drawer, so it will be a drawer layout, or the swipe to refresh layout is also another example for creating screen interactions. It actually doesn't happen on many occasions. On the other hand, you do this also for increasing the performance of your application. It's because there's a problem with Android layouts. The native view groups are frame layout, linear layout, and relative layout. None of the three are very flexible, and for implementing your design, you will actually have to put one of them inside the other and get a deep layout, which the deeper your layout gets, you will exponentially get worse performance. Like after the third or fourth steps, you will start to realize actually the lags and the things not being as smooth as it should be. And it happens when you have many views on your screen, which means you will have a complexity on placing them, and you will fall into the need. And also on many cases that you have a list. Each item has its own layout, its own complexity, and it's in the screen that has its own layout, and things get complicated and slow. It doesn't feel very nice. Android actually tried to solve it by introducing the constraint layout. Let me show you here. It's here. Yeah, the constraint layout. It's put in your Gradle file by default now. The constraint layout has a much better flexibility. Actually, you can do most of your design implementations using it, but there's a downside, which is the constraint layout is also slow, and especially when you have a list, or you have a constraint, when you put a constraint layout inside another constraint layout, it becomes an absolute disaster. Like imagine your list items are constraint layouts, and you put it inside your whole layout, which is also another constraint layout, and it's not good. It's terrible actually. So this actually forces most of the times that you extend the view group directly, and again bypass all the extra calculations and just tell each view where to be and position them and be done with it. On this note, actually, after realizing the problem with the constraint layout, I got inspired by it and how it works, and I came up with the sequence layout. It's much more flexible than constraint layout. You can do things that you could not imagine that is possible. Also, the performance is great. It's as good as it can be. It doesn't do anything extra. And since I created this, I have not needed to extend the view group anymore, because the performance is good and works. I will put a link to it in the descriptions of the video. You can check it out. It has descriptions and everything. And last is to extend the view group subclass. Whenever you do this, you're actually modifying an existing compound view or creating a new compound view. Modifying compound views is similar to extending a view subclass, and the challenges are the same. And creating a new compound view is when you have some elements on the design that are related to each other and their behavior influence each other, and so or sometimes just because some views are repeated together and they do not actually depend on each other by the behavior, not by the identity. So you just pack them together as a new compound view with the behavior it has and the methods. For example, you can pack a bunch of views together to, I don't know, like a user view, and it gets like set user, and you give it the user object and it sets everything. So whenever you want to show the user, you just put a user view there. Or like another case is to, I don't know, like a different kind of date picker. It's also packing a bunch of views together and it becomes a date picker with like set date methods and get date and stuff. So that's it. Okay, now there's something you always do when you want to extend to create a new custom view. You do this every time with no exception. Imagine I want to create a custom view, and it doesn't matter which class you're extending. Either it's say like a view or a subclass of view. It's always the same. First, you put all the default constructors except the last one. It's deprecated in the new versions of Android. This is the first. You have to have all the default constructors. It's a must. Then you define a method called private void initialize with these parameters of the most complete constructor. The third, you call this from all of your constructors. You do this every time. Okay. Now you can do your initialization code here. It's simple. It's because you want your initialization to run anyways, and also you have to have all the constructors, so this is what you have to do every single time. Okay, now let's explain the constructor, just because I want you to understand why we have to have these constructors here is because of a class called the LayoutInflater. Let me create activity subclass, main activity, public class extends activity. Okay, you see, I showed you the setContentView method that receives a view, but actually what we use most of the time is that we give it the layout resource file ID, which happens here. You create a new resource file like activity main, and its root element. I don't want it to be constant layout, like just I want to put just something there to show you. And we have a text view, for example, like this, and the text says hello, something like this. So what we do here is we call setContentView and reference the XML file. What happens behind this method is actually there is an object called the LayoutInflater, which receives the resource and opens it as an XML file, and actually reads all the tags and the attributes and create the view related to all of this hierarchy and returns them. And the way it does it is using the reflection. Let me show you the class first. The layout inflater is this. Layout inflater dot. Okay, so this is how you get your layout inflater from a context object. But actually, in the activity, you can get it directly like this, and you can see the method inflate, which says the resource ID and the view root, which can be null. We'll discuss it later. And also the XML parser object does the same. So how does it do this? It starts reading the XML file. For native views like the frame layout, text view, or like image view, everything, it actually has this string predefined in it, and it has it associated with the like frame layout class, which is android.widget.framelayout, and it resolves the tag to a class object. Like I can reference the custom view here, the newly created custom view. You see, for non-native views, you have to write the complete name of the class. The complete name is the package address along with the class name. So the layout inflater reads this, converts it to a full class name, and then uses reflection to find the class, and according to the attributes that are written here, it decides to find the related constructor. Using reflection, it means that it expects a constructor with this format or this format or this format to exist. And if you don't have these constructors, you might get an exception. What happens behind? Like I can show you. Class name. Imagine the class name has been resolved to this. So what happens is, like, the class is now going into reflection, we have a class loader. You can access it directly. Dot get system class loader. The system class loader is the class loader that exists when the Java virtual machine is created. And it does not include the classes you have in your project. If you want the classes you have in your project, you have just take the class loader from one of your existing classes, like main activity.class.get class loader. This one has all the classes I have in my project. So this is the class loader, and I ask it to load the class name, and then using the class I can get the constructor. Class.get constructor, like context class, and let's reference this method. Attribute set.class, and integer dot. It must have a native type. Okay, let's ignore it for now. So this is asking the class reflection object to find this constructor, class object, and an attribute set object, which resolves to this. And then custom view, it actually doesn't care about it. It calls a view equals to constructor.new instance, this as the context and null as the attribute set, for example. And okay, so that's it. It requires a cast too. So this is actually what happens in the layout inflater. you get an exception if this class doesn't exist, which means you have written this name incorrectly. It gets an exception if it doesn't find the constructor. It gets an exception if you throw an exception in your constructor code. If your constructor gets an exception, you will get an exception here. Means while the layout is being inflated. Means in your setContentView method, you might get an exception, which if you do, you can actually find it in the log, and it's not a big deal. So you know what the layout inflater is and what it does, and why we can do this here, and why we have to have these three constructors every time. Okay, that's everything I wanted to say for this episode. Don't forget to like and subscribe. This is Open Code Wheels. Have a wonderful time.